So yesterday we worked through this awful problem, and we found our possible rational roots, and then we tested our roots to see if they came up with the right one, and then plugged it in, or factored it out, then used the quadratic formula for the last one. So these steps will be required. The only difference with your homework is that you don't have to actually just guess at which roots there are. You're going to need to go to Desmos and pick it out. So we're going to do another example of how to do that today, and then move on to a word problem. And so now I'm just going to walk through these same steps over again. So the first thing that I need to do is start with my P and Q. So where does my P come from? First I have to find my factors of P. P is our last number. Q is our first number, or the leading coefficient. So I start by finding the factors of P. What goes into 8? Well, I have 1 and 8. Now, if you remember from yesterday, this could be plus and minus 1, plus and minus 8. What else multiplies to give me 8? Could be 2, plus and minus, and 4, plus and minus. What multiplies to give me Q? That would be 1 and 5, plus and minus 1, plus and minus 5. And that's it. There's nothing else that will multiply to give me this. So now I need to find my possible roots. So this will just tell me what numbers I need to use. And now I just start working. 1 plus and minus 1 over 1, which is just 1, plus and minus 1 over 5. And you can list these in any order. Plus or minus 2, plus or minus 2 over 5, plus or minus 4. I'm doing 4 over 1. Remember, it's P over Q, plus or minus 4 over 5, plus or minus 8, and plus or minus 8 over 5. Those are all my possible roots. Okay. Now we would need to test the possible roots to see if it's a factor. Now, yesterday when we did it, I did it just starting with 1. However, you don't have to do that. I'm going to allow you to go to Desmos and pick out your root. So let's get started on that. So now when I go to Desmos, I'm going to enter my equation in. 5x to the third minus 2x squared plus 20x minus 8. If I scroll out or scroll in, you can see that my graph is currently only crossing at one spot, and that's at 0.4. So what is 0.4? We need to think of what 0.4 is. Is 0.4 1? Obviously not. Is it 1/5? If you put that in a calculator, that would give you 0.2. This is obviously just 2. It's not 2. This would be 0.4 or negative 0.4. So let's go ahead and put 0.4 in. Now this is where it gets fun because we haven't had to divide by a fraction using synthetic division. So I'm going to do 0.4, 5, negative 2, 20, and negative 8. Five comes down. 0.4 times 5 gives me 2. Negative 2 plus 2 is 0. 0.4 times 0 is 0. 20 plus 0 is 20. 0.4 times 20 is 8. Negative 8 plus 8 is 0. Start backfilling. I now have 20. That's positive. 0x and 5x squared. Since this is a 0x, it means that there's no x there at all. So really, this is just x minus 0.4 times 5x squared plus 20. Now, because this is just 5x squared plus 20, I don't have to use the quadratic formula. I can try to use the quadratic formula to solve this. Once you get down to an x squared, you know you can use the quadratic formula to solve it. But I could also, since there's no x in the middle there, just take this and set it equal to 0. 5x squared plus 20 equals 0. Subtract the 20 over. That gives me 5x squared equals negative 20. Divide by 5. I get x squared equals negative 4. Take the square root. Now, if I take the square root of a negative 4, it gives me an imaginary number. So I know that this is not going to simplify any further. Because I'm looking for the real roots. If I was looking for complex roots as well, then that would be a possibility. However, I can't do that, so it stops here at x minus 0.4 and 5x squared plus 20. So in other words, this is my only root. If I'd use the quadratic formula for this, second part, negative b, there is no b because it was 0. So that would be 0 plus or minus the square root of 0 minus 4ac, that's 5 times 20, all over 2a, would be over 2 times 5. Square root, negative 4 times 5 is negative 20. Negative 20 times 20 is negative 400. I can't take the square root of a negative, so I'm done. This is my only root, and it would be at x equals 0.4. All right, let's do another example. I just grabbed one of your homework problems. So, in order to do this, first I take this and find my factors. P, that would be 1 and 7. Don't forget about your plus and minuses. And find the factors of 4. That's my Q. 1 and 4 and 2 and 2. Plus or minus, plus or minus. Because it's 2 and 2, I only have to list the 2 out once. Now list out my possible roots. 1, plus or minus, 1 divided by 1. Then I do 1 divided by 2. So that's plus or minus 1/2. And 1 divided by 4, plus or minus 1/4. And do the same thing with 7. 7 divided by 1, plus or minus 7. 7 divided by 2, plus or minus 7/2. And 7 divided by 4, plus or minus 7/4. Do a terrible squiggly bracket like I did. Let's go into Desmos. We will redo our equation here. Make minimal changes. But you can see those minimal changes made a big impact in my graph. And so I can start by trying to find some of these points. The first one I can try is negative 0.5. That's going to be easier than the other ones. Negative 0.812, I don't want to plug in. Or I don't want to try to use that for synthetic division. I don't want to try it with 4.312 either. Once I find one root, it's going to help me find the rest. So I'm going to go with negative 0.5, especially because we're only to the third power, which means I'll be able to use quadratic for the rest of them. So, do negative 0.5, and it's 4, negative 12, minus 21, and minus 7. Bring down the 4. Negative 0.5 times 4, that's going to give me negative 2. Negative 12 minus 2 is negative 14. Negative 0.5 times negative 14 is going to give me a positive 7. Negative 21 plus 7 is negative 14. Negative 0.5 times negative 14 also gives me 7. Negative 7 plus 7 gives me 0. So this is a factor we kind of knew it was going to be anyways. Now I backfill negative 14, negative 14x, and then 4x squared. And when I plug this in, don't forget to switch your sign. It's x plus 0.5. But I don't really even have to plug it in. It just shows me that the equation is correct. Now this I can use the quadratic formula on, or I could try to factor it. I'm not going to factor it. I'm going to use the quadratic formula, especially because we already knew that it gave us decimals. So since it gave us decimals, it's not going to be factorable. So let's go ahead and use the quadratic formula on this. Negative b, remember a, b, c. Our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug your negative b in. That's negative of a negative 14, so it's positive 14 plus or minus the square root of negative 14 squared minus 4 times negative 14 all over 2 times 4, which is 8. All right, so that's 14 plus or minus the square root of 196. Negative 4 times 4 is negative 16 times negative 14. So that's 224. So that's 14 plus or minus 196 plus 224, which is 420. Over negative 8. Square root of 420 is 20.49. So this is 14 plus or minus that, so 14 minus 20.49 divided by negative 8. And that gives me 0.812. Negative 0.812 because it's a positive. Then I can do the minus version. or the plus version, I mean, 14 plus square root of 420 divided by 8, which gives me 4.311 or 4.312. So those would be my three roots. If I'm looking at whichever ones these are up here, those aren't going to be any of those. Do you know why? It's because this number that I get here is an irrational root, and so is this one. So I guess I've been teaching us too much. Whenever we do the quadratic, if I don't get a whole number or one of these up here, then it's not going to work. So basically, just do this step because you can learn about irrational roots now. Right? No, this is real roots, so we're good. We're good doing that. If you leave it at this step here, you're in good shape. So you don't actually have to come up with those ones. It's good to solve this out to make sure that it comes up with the same roots that we have. And then we also have this one, which was x equals negative 0.5. For a second, I thought we were only supposed to find rational roots, but this is all the real roots, so no big deal. All right, lastly, we're going to hit up some word problems. The design of a box specifies that its length is 4 inches greater than its width. The height is 1 inch less than the width. The volume of the box is 12 cubic inches. What is the width of the box? So write an equation to model the volume of the box. Remember, the volume of a box is length times width times height. So if I let x represent the width, volume equals length times width times height. You can do that in any form. So my volume is 12. My length is x plus 4. My width, you're going to see me rewrite this, is x, because it doesn't matter what order I put them in. And my height is x minus 1. So now I have to multiply this out. X times x is x squared. X times negative 1, that's negative x. Inside is 4x. 4x minus x gives me 3x. And then last is 4 times negative 1, so that's minus 4. And this is still times x. So now I distribute my x. It gives me x to the third plus 3x squared minus 4x equals 12. And I'm going to set this equal to 0, so I'm going to subtract my 12 over. X to the third plus 3x squared minus 4x minus 12 equals 0. Now I use my rational root theorem to identify all the possible rational roots. So I'm going to find my factors of 12, or negative 12, plus or minus 1, 2, 3, 4, 6, and 12. And then I have to find my q, which is just 1, so that's plus or minus 1. Makes this problem easier. Now we use our rational root theorem to identify all, that's what we just did. Step 3, we start testing the possible roots to find one that is actually a root. The width must be positive, so try only the positive rational roots. In other words, since I know it's going to be a positive, I can't have a negative width. So all I really need to be trying is 1, 2, 3, and 4, then 6 and 12. So forget this table for a second. I'll show you what that means here shortly. We can go back to our equation, x cubed plus 3x squared minus 4x minus 12. That would be 1, 3, minus 4, and 12. And then I can start using my rational root theorem, or I can start testing the roots that I came up with up here. So if I start with 1, bring down the 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. Negative 4 plus 4 is 0. 1 times 0 is 0. Negative 12 and 0. That leaves me a remainder, so we know it's not 1. And try 2. Bring down the 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. This gives us 6. 2 times 6 is 12. I get no remainder. So I'm done. My x is 2. So now that I found an x equals 2, I would normally have to finish this out. X squared plus 5x plus 6. I can factor this. But there's an easier method. Here I have 2, that's my width, right? If I go back to the beginning of the problem, the length is x plus 4. 2 is my width. 2 plus 4 is my length. My height is 2 minus 1, so that's 1. So now I found everything I need. My length, my width, and my height. And actually, it just asked for what is the width of the box. So I guess we went too far here. All right, well, that is it for today. Hopefully that helps you with your homework. Remember, on your homework, you can use Desmos, but you have to list out all the possible roots first, and then you can use Desmos to identify your real root. You still have to show all of your synthetic division, though. So don't forget that.